Our video tutorial is about derivatives of some trigonometric functions. So let us find the derivative of this function f of x equals x squared times tangent x. This is the product, so we will use the product rule. So the product rule, its derivative is equal to the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. So we have also the derivative of tangent x is equal to secant squared x. Let us apply this rule here. So it is the first factor x squared times derivative of tangent x is secant squared x plus tangent x times derivative of x squared, which is 2x. Then simplify and move outside common factor x. So this is the derivative of the function. Next, find the derivative of g of theta equals theta over 1 minus sine theta. So this is quotient. We will use the quotient rule. The derivative of quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. And derivative of sine x is cosine x. So this is the derivative of g of theta. G prime of theta equals denominator times derivative of theta with respect to theta is equal to 1. Then in the formula, minus the numerator theta times derivative of the denominator. This negative here is this one, and the derivative of sine theta is cosine theta. So distribute this one and negative theta inside on its term. Simplify. So this is now the derivative of g of theta. Next, find the derivative of y equals negative cosecant x minus sine x. We have here the derivative of cosecant x equals negative cosecant x cotangent x, and derivative of sine again is cosine. So we leave this negative, bring down. The derivative of cosecant x is this one minus derivative of sine x is cosine x. Simplify, distribute the negative sign and express this in terms of sine and cosine, and simplify the fraction, combine the fraction into 1 and factor out the common factor cosine x. From the Pythagorean theorem, we have here, if we are going to solve for cosine squared x, we come up with this expression. So substitute. Then express cosine squared x over sine squared x in terms of cotangent. So this is the derivative of our function dy dx. Next, find the derivative of y equals x squared sine x plus 2x cosine x. So again, the derivative of sine and cosine. And here it is product. So we will use product rule. So the derivative is equal to x squared times derivative of sine, which is cosine, plus sine x times derivative of x squared, which is 2x, plus, this is again the product, 2x times derivative of cosine x is negative sine x, plus cosine x times derivative of 2x, which is 2. Then simplify, combine similar terms. So factor out common factor. So this is now our derivative of the function. Next example, find the derivative of y equals cosine of square root of 2x plus 1. So we will use this time the chain rule, because cosine of a function is not as simple as x, but it is a function square root of 2x plus 1. So again, derivative of cosine is negative sine x, and we have here the derivative of the square root. So derivative of square root of u is equal to 1 over 2 square root of u times derivative of u. And our u in our problem is square root of 2x plus 1. So that dx, derivative of u with respect to x, is equal to, using this formula, 1 over 2 square root of 2x plus 1 times derivative of 2x plus 1, which is 2. So here, first we have to get the derivative of cosine, which is negative sine of this function square root of 2x plus 1, times the derivative by the chain rule times the derivative of this u, which is this one. Multiply 1 and 2, then cancel out 2, then simplify. This is the derivative of the function. Next, find the derivative of y equals sine cube x minus cosine cube x. This is power, so we will use the power rule. Derivative of x to the n is equal to n times x to the power of n minus 1. Our power here is 3. So again, derivative of sine cosine. So first we apply the power rule. This is 3 times sine of 3 minus 1 is 2 sine x. Then the derivative of the base, our base is sine x. Its derivative is cosine x minus, starting from the power, 3 times cosine, 3 times cosine of cosine x to the power of 3 minus 1, which is 2, times the derivative of the base, which is cosine x. Its derivative is negative sine x. Simplify. Then if there is something to be factored out, factor it outside. So this is now our derivative of the function dy dx. Next, find the derivative of y equals square root of tangent of quantity x squared plus 1. So this is the derivative of tangent x is equal to secant squared x, and derivative of the square root of u is equal to 1 over 2 times square root of u times the derivative of u with respect to x. So let us apply here. Derivative, okay, so this is, we use the derivative of square root. So our u here is tangent of this quantity x squared plus 1. So 1 over 2. So 1 over 2, this is our 2, and our u is tangent of this quantity. Our du dx is the derivative of tangent, which is secant squared of this u, this quantity, times by the chain rule, we still have to get the derivative of this u, rather tangent of u. So it's the derivative of x squared plus 1 is 2x. So this is now the derivative, cancelling out common factors and rewriting the expression in simpler form. So this is the derivative of the function dy dx. Next, find the derivative of y equals x squared over square root of 1 minus sine 2x. So this is quotient. We will use the quotient rule, and our denominator is square root. We will use the function present there is sine x, so its derivative is cosine x, and we have the denominator square root of minus sine 2x. So this is our derivative. So the derivative dy dx is equal to, using first the quotient rule, it is the denominator here times the derivative of numerator, derivative to x squared is 2x, minus the numerator times the derivative of denominator. So derivative of square root of 1 minus sine 2x is this one, 1 over 2 times square root of u. So this is our 2 times square root of 1 minus sine 2x, and du dx, derivative of u, derivative of 1 minus sine 2x is, by the chain rule, derivative of negative sine 2x is, the negative is here, the derivative of sine 2x is cosine 2x, plus times the chain, by the chain rule, times the derivative of 2x, which is 2. Then simplify, cancel out common factors, then distribute the sign. Here, negative becomes positive. Then, express as a single fraction. This denominator is expressed as a single fraction. So we have here this denominator, square root of 1 minus sine 2x times square root of 1 minus sine 2x becomes, square root is eliminated because of multiplication, plus the numerator all over this denominator and all over 1 minus sine 2x. Simplify and perform the operation of complex fraction, so the denominator is inverse. Then multiply. The denominator we will multiply in terms of the exponent. So the exponent of 1 minus sine 2x is 1/2. Here its exponent is considered to be 2 over 2 or 1. So as we multiply the denominator, it becomes 1/2 plus 2 over 2 is 3 over 2, or in radical form, that is square root. The denominator here becomes is the index of the radical, and the numerator is the exponent. So this is the derivative of the function. Okay, next, find the derivative of y equals square root of 1 minus cosine 2x all over 1 plus cosine 2x. We can distribute the square root on both numerator and denominator. So this is now quotient. We apply the quotient rule. Okay, applying the quotient rule, with derivative of cosine is negative sine, and derivative of square root is this chain rule. Okay, so dy dx is equal to denominator square root of 1 plus cosine 2x times derivative of the numerator, which is square root of 1 minus cosine 2x. Following this derivative, we have 2 times square root of u, or 2 times square root of 1 minus cosine 2x times the derivative of u, derivative of 1 minus cosine 2x. Okay, so this negative is here. The derivative of cosine is negative sine. So this is negative. Times, by the chain rule, derivative of 2x is 2. Okay, then minus numerator, this one, times the derivative of the denominator. So derivative of square root, again this one, we have here 2 times square root of 1 plus cosine 2x times derivative of 1 plus cosine 2x. Derivative of cosine is negative sine 2x. By the chain rule, derivative of 2x is 2. Okay, then cancel out what is common on both numerator and denominator. Then simplify, distribute negative sign. So after that, we are going to transform these two fractions in a single fraction. So the LCD is the product of these two denominators. So this square root of 1 plus cosine times this square root of 1 plus cosine to x, the square root symbol is removed. This square root times this square root, which is the same inner function of the square root, when they are multiplied, the square root symbol is removed. Then distribute sine 2x Okay, distribute sine 2x in each of the term. Then take note of the opposite signs. They are cancelled out. So we have sine 2x plus sine 2x. Combine them. Then perform the operation of complex fraction. Here we have 1 plus cosine is the same as 1 plus cosine to x. The exponent of this quantity is 1/2 and the exponent of this quantity is 2/2 or 1. So when they are multiplied, following the laws of exponent, so this is the exponent of this is 1/2 and plus 2/2 or 1, that becomes 3/2. Or in expressing this in radical, okay, the denominator of the exponent is the index of the radical and the numerator is the power or exponent times this quantity. So this is our derivative. So that's enough.